So here, if you're looking at this problem, we have a stated design requirement. We're given an IP, Class B address 165.10.0.0, and we need at least 150 subnets that have no more than 200 hosts apiece. And we know we'll be looking for a subnet mask. And it may not state this explicitly, but you know that's what you'll be looking for. Which of the following subnet masks, for instance, should we use type question? And we got to figure this out. Now, as you're considering something like this, a design requirement of at least 150 subnets, by the way, in reality, in the real world, you've got to have usually a certain amount of consideration for the future. You try to plan for future growth. That's what you've got to watch out for. You don't want it to be useless in 6 months. Like if you're actually going to put 190 hosts on a subnet, you should go for more than 240 or 250, for instance. Plan ahead. But let's take a look at how we'd approach this particular kind of question. And in this case, we know that it's a Class B network. We know that our default mask is... Now, how many network bits and how many host bits do we have in the default mask for a Class B? You remember that one? Well, let's see. Here's our mask, okay, in dotted decimal. Or it's /16 in slash notation. And we've got 16 network bits and 16 host bits. What do we do now for subnetting? What do we call it? It's the process of borrowing bits from the host, not the network. So we look at this requirement, and we've got to hit both requirements. We don't want to be half right. So we got to figure out the number of subnets. We need 150 subnets, right? And then we know it's some power of 2. So what I do is I just start writing down 2's and multiplying them out. Very quickly you'll get to the point where you can just eyeball it and you will know right off the bat in your head what the number will be. But at the very beginning, be explicit. Let's write this out. Be methodical and master this. So times 2 equals 8, times 2 equals 16, times 2. This isn't scientific, but it works. I just scribble it out. Times 2 equals 32, times 2 equals 64, times 2 equals 128. Getting warmer. Need 150, so the next one will do it. Times 2 equals 256. Now that's well in excess of what we need. We need 150. 128 is too few. 256, even if it's -2, is well within our requirement. So right there, we're saying we need to borrow 8 host bits to give 256 valid subnets. So we figure that out, and we're all done, and there's a choice on the exam. We're looking at the answers, multiple choice here. It says, okay, we've got 8 subnet bits, and this is our mask, 255.255.0.0 or /16. Then what would that be in dotted decimal? It'd be 165.10.0.0, 255.255.255.0, because we've got 16 network bits already set to 1. And we're borrowing 8 subnet bits, right? And if all these 8 bits are set to 1, we know that's 255.255.255.0. Or it's /24, because we are CCNAs, CCNPs, and CCIEs, by golly, and we know what prefix notation is, so we leap upon that, we select it as an answer, and we hit the next button because we nailed it. No problem at all. It was easy to figure out. We go on to the next one, not knowing that all the time we were wrong. And we missed big points on this one. And this is a case where we're here to score points, not give them away, but can you tell me why we went wrong and missed some big points here? Because this was a bigger problem. It was a 2-part problem with 2 requirements, and we met only one of them here. If we did just that and moved on, we met only one of the requirements. Because What it also said was no more than 200 hosts per subnet. And if we had gone on to actually figure that out, if we borrow 8 subnet bits here, how many host bits do we have left? We had 16, borrowed 8, and that leaves 8 host bits. So now what have we got then in that case? We've got 2 to the 8th power minus 2. We know that 2 to the 8th is 256, and minus 2 is 254 valid hosts. And that violates the second requirement because it exceeds 200. We got the answer wrong because we did only the first part. And yeah, I set it up and left it like that just to demonstrate the purpose, because this goes for the real world too. You'll run into the exact same situation for one reason or another. Say I'm a senior admin and I had you do this and figure out something for a new subnet for our network, and you gave it back to me like that, and I'll know you didn't calculate the number of host bits in this case, and that's not good. So what it seems like we maybe want to do in this case, though, to fix it, is to borrow another subnet bit, because we were told at least 150 subnet bits. And remember, we had more than we needed, way more than we needed. So if we borrow one more host bit, that gives us 512, right? Correct. So let me just throw that in. Calculate times 2 equals 512. Just have it written down. So that results in 512 valid subnets, and that's 2 to the 9th. And that in turn leaves for host bits how many? 2 to the 7th. Oh, that's 7 host bits. How many valid hosts is that going to be? Well, 2 to the 7th is 128. And that does actually meet the second requirement, if you look at it. So what we actually end up with is 9 subnet bits. We need 9 subnet bits. 7 host bits. These masks are wrong. They did not meet the requirement. Now what would? If we had those 9 subnet bits and 16 network bits, that's 25 bits. And what's that in dotted decimal? If you lay it out, it's 255, 255, 255, 128, or /25. Because we borrowed 9 subnet bits, not 8, to meet the requirement. And this is not a trick question. This is actually standard. This is what you're asked on the job. It happens all the time, this type of a question, exactly this type. The certification exam is very job-oriented, and this is one of the questions. It's not tricky. You just gotta know and understand. You're practicing hard to understand and master this, and you're there to take points and to take the certification home. And then when you're playing the big game, you see and understand the requirements, you will succeed. I guarantee it. I'm sure you can see now from this that it's easier to just understand the math than to learn any special tricks. It's all very straightforward. But I guarantee that if you try to learn the tricky way of doing this, 3 weeks after the exam you'll forget it. 3 days in most cases, I think. I know that if I talk to somebody who took the exam a month or 3 months ago, and I ask them something about subnetting, you watch their eyes roll back in their heads as they try to remember some nonsense they memorized. All you've got to do is practice these basics, and you have it nailed. And this will give you a confidence that you won't believe. And I know you can master this easily. It's easy. Just got to practice a little. Write your own questions. Start writing your own questions. It'll help you grasp the concepts. And once you know the basics, you do this yourself, start making stuff up, analyze real situations as you run into them. Speed doesn't come from clicking real fast or from writing real fast. Speed in the exam comes from competence and certainty. And that is what we call excellence. It's from knowing what you're doing. Practice excellence. Speed comes from the excellence, and you're not questioning yourself. That is what you're shooting for. You do it, you move on. So all of this stuff, this was your intro to binary math and subnetting. And when you're at the point where you can make up your own subnetting questions and solve it, you'll find that that'll help you tremendously on the exam. Not to mention in real life, it's a confidence booster, that's for sure. You'll see some more advanced examples of this stuff when you get into the variable length subnet masks. They just want you to know the basics because, again, as we've seen, basics are what it's all about. So I hope this has been informative, and I hope you actually enjoyed it a little bit. I'll see you next time.